just start with your talk.
Sure. Hi, everybody. My name is Ram. This is going to be my talk about PySnooper. PySnooper is an open source project of mine that I released a year and a half ago. So this talk is going to be about what it is and how it can help you. And it's also going to be about the concept of making a popular open source project and how you can make it and how you can make your open source project successful. So as Amna said, if people have questions during the talk, I'd be happy if people interrupt me and ask them on video, and I'll be happy to answer. Anyway, you can see the code at this address, or just Google for PySnooper. And first, I'll introduce myself a bit. My name is Ram Rachum. By the way, I haven't mentioned, I am here in Tel Aviv, Israel. I'm a long-time Python developer. I'm known for my projects PySnooper and Python Turtle. I've contributed to a bunch of open source projects like CPython, Django, and PyPy. I organize PyWebIL, which is the Israeli Python community, and I'm a member of the PSF and the EuroPython Society. So this is going to be a talk about PySnooper. I'm going to show you the GitHub page. So this is the GitHub page for PySnooper. We're going to talk about a bunch of stuff in it, but it says that PySnooper is a poor man's debugger. So PySnooper is a debugging tool. So I'm going to explain a bit. I'm going to talk about debuggers a bit. I'm going to explain about debugging with a classic debugger. I'm going to talk about why people end up using print statements or log statements to do debugging instead of using a debugger. I'm going to talk about how PySnooper is a compromise between these two solutions. I'm going to show you how to use PySnooper, maybe talk a little bit about how it works. And I'm going to talk about what it's like to make a successful open source project. And I will also show a different tool called PuDB. There is another debugging solution that I really like. Let's get started. And I remind you that if you have questions, feel free to interrupt me. So I'm going to talk a little bit about debuggers. Debuggers, you use them when you have a bug in your code and you want to figure out what is your code doing, right? We've all been in the situation where we have a code and it's frustrating us because it's doing the wrong thing. And we look at the code and it looks like it should be doing something, but it's doing something else. So we try to dig into it and figure out what it's doing. So my favorite tool for that is a classic debugger. And I've got a piece of code right now. If you can't see the code on my screen clearly, please let me know. I've got this piece of code on the screen now, just random code I copied off the internet. It's a function that takes a number and converts it to bits. Let's run it. I'm running it in my IDE. It's called Wing IDE. I know that most of you probably never heard of it, but it's basically like PyCharm. It's the hipster version of PyCharm. So I'm running this function now, and I'm giving it the number 6, and it's giving me the output of 110. So it's taking the number 6 and converted it to binary. So that sounds very interesting for us. It's just a case study for us to use a debugger to look into what a function is doing. So when I go with my debugger, I can set a breakpoint. Like right now, I'm setting a breakpoint on this line of code. And I'm going to run it now. And when I run it, the IDE runs the program and it stops on that line. And then I can use the shell to figure out the values of variables. Like I can say that the value of the variable number is now 6. I can step through the code line by line. And at every point, I can use the shell to look at the values of variables. Now the variable number has changed. I can look at the remainder. I can look at bits. I can step into functions, step out. I can look at the call stack, right? I've got the tool here for the call stack. I can do a lot of powerful things. And that's kind of my favorite way of programming. I really like to use this kind of full-fledged debugger. And now I'm getting to the second part of things I want to talk about is that people, I mean, one of the things that I discovered when I started working professionally is that so many people, so many professional Python developers, they don't use classic debuggers that way. And I guess they have lots of reasons, but one reason I found out is that because it's difficult to set up, especially when you're working for a big company. like when you're working at home on your own fun projects, like I was working just now on just one Python file, it was very simple because I just one file, I ran it in my debugger, I put a breakpoint, everything was easy. But if you're working for a company, especially a big company, the environment is usually more of a mess because 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 the code, I mean, I don't know, maybe you work for a company where you are maintaining a web server in Django, and it's not really running on your machine, it's running on a different machine. And maybe that machine is in a Docker container or in a VM, and maybe it's on a different operating system than yours. And most people don't really know how to connect their classic debugger to that kind of setup. Now, it is possible, both with WingID and PyCharm. They both support remote debugging, but most people don't know how to set it up. It's pretty complicated. So that's why people end up doing this instead. Oops. Right? I think we've all done things like that to understand what the code is doing. So right now, if I were to go to the shell, I could run the code. I could run the code and I would see these lines getting printed. Entering loop, loop run, loop run, loop run, loop ended. And now that kind of gives me a glimpse on what the code is doing. And when you do stuff like that, you usually add variables, right? You want to know what the value of the variable number is. You want to figure out what's going on there. So you add this detail, and now you see for every run of the loop, you see the number is 6, number is 3, number is 1. So that's kind of this crude method that everybody keeps on doing, just because it's so reliable. I mean, it just works everywhere. It doesn't matter how complicated your setup is. You can always print or write to a file or to a logger or whatever. So that's what people end up doing. And this method is also so annoying because you have to kind of put these print statements in your code and you have to decide where to put them, right? Yeah, I mean, usually you have code that's much more complicated than this, and you're putting prints in different places, and you have to decide which variables you're going to expose. Let's say right now, I would decide that the variable number isn't enough, and I want to see remainder as well. Then I would add the variable remainder. And now I have a problem that it didn't exist, so I will expose a different variable called bits. And now I will see this variable, but you have to do this back and forth all the time. And in this example, the back and forth wasn't too painful because I just pressed a button and the code ran. But if you're working for a big corporate client, building the version of the code and getting it to run can take a few minutes, and having to do this back and forth all the time really drove me crazy. It really drove me crazy to see so many of my colleagues use the same method. So now we're getting to what PySnooper is and how it is like a compromise between the two. So I figured maybe I can do something that is as reliable, as easy to use as print statements, but also a little bit more powerful like a debugger, and gives you visibility into what's happening in your code. So that's PySnooper. I'm going to show you how to use it now. I'm going to delete these print statements and remove the breakpoint. And I'm importing PySnooper. Obviously, I skipped the pip install PySnooper, but you already knew that. And I'm decorating my function with PySnooper.snoop. There are a bunch of options here that Wing helpfully showed me, but I'm going to talk about them later. So now I'm going to run the code like I did before. Okay, I just got a huge text dump on my screen. So let's make my font a little bit smaller. Okay, I got a huge text dump. And at the end of the text dump, I got the same answer I got before, 110. This text dump is the sort of a product of PySnooper. This is the information that you get from it. And what you get here is a sort of a automatic log of your function. It's basically giving you sort of a play-by-play for every line that ran in your function. It's telling you exactly when it ran and which line ran and the line number and any variables that got declared or got changed. This basically has the effect of, instead of going back and forth and putting print here and print there, it just puts a print statement everywhere. And you get a big dump of input, output. But if you look at it, you get a real good narrative of what happened. So I can see that the function was called. And then we initialized bits. And then we ran the loop the first time. And the variable number got modified from 6 to 3, and we declared a new variable remainder. I can see basically everything that happened in the function. So that's the basics of what PySnooper is. There are a bunch of options, a bunch of fancy features, but that's pretty much the basic. And you can put it on any kind of complicated function and just get a detailed output of everything that happened. Does anyone have questions so far? If so, feel free to unmute yourself and ask, or maybe in the chat or something, I don't know.
I know that someone just posted in the session Q&A, wow.
Cool.
And there was a question, if you want to already answer it before the talk, that can we embed into our IDE or text editor? Maybe you plan to answer it later.
I saw that question. No, not as far as I know. It is a tool to use a sort of in the console or writing to a file. And you know what? That's a good lead into the next thing I wanted to show. So when I started showing the Snoop decorator, you might have seen there were a bunch of options there. So you could look at the README to see the documentation for all the options, but I'm just going to mention a couple of them. So one interesting one is I can put in a file name here. I can say log.txt, and then when I run the code, it will not output them to standard error, but it will just output them to a file called log.txt. And in the same way I use the file name, I could put a callable there or a logger, and it's just gonna dump the text into there. So that's one useful option. Another useful option is watch. I can tell it to watch any kind of Python expression. For example, let's say I wanted to track the length of the variable bits. I would add this watch expression, and then I would run the code. And besides the usual text dump, it will always report to me on the length of the variable bits. First it's 0, then it's 1. Every time it gets changed, it's going to report it to me. And I can put any kind of complex Python expression in there. I can call functions and add things up or whatever. I can basically, it's basically very similar to the watch feature of any full-fledged debugger. And another, that's the last feature I'm going to show. Actually, I'm not going to show it, just going to talk about it because it's not, because it can't really be used on this function. There is a flag called depth, and depth is 1 by default. And a depth of 1 means that PySnooper is giving me output only for the lines in the function that I'm now decorating. And depth equals 2 means I'm getting output for all the lines in my function and all the lines in every function that my function calls. So going to a depth of 2, and I can do depth of 3 or 5 to get a lot of text. And I've sometimes done depth equals 1,000 to get basically everything that ran. And it is slow and it makes a huge text dump, but it's also pretty useful because a huge text dump is still something you can search through. You can use regular expressions to find things, which can sometimes be simpler than going back and forth with the debugging. So these are some useful features. Sorry, more things I want to talk about. Okay, so people have asked me, how does PySnooper work? I mean, what is this magic that lets me automatically print stuff in the middle of your code? So let's dive into the PySnooper code base. There's lots of complicated code here that does a lot of things to make PySnooper convenient, but the most important part of the code, sorry, is this line. sys.setTrace. Maybe you're familiar with it. Sys.setTrace is a functionality of Python. It is a way to tell Python itself, please run my tracing function between every 2 lines of Python code that you run. And then you use that tracing function to do your logic. Now, any kind of debugger that you've used in the past, like PuDB, they use the same sys.setTrace functionality. This is the sort of a core of every kind of debugger or code intelligence tool or like coverage measurement tool. They all use sys.setTrace. So CPython itself is doing the heavy lifting, and all it's doing is just calling my trace function, which is a big function that I have that takes the current frame, the event, and the argument, and figures out what to print. So basically, if you wanted to implement a debugger or anything that is similar to PySnooper, you would use the same sys.setTrace as I have and just put your own logic in your own tracing function. So that's it for how PySnooper works. I'm gonna talk a bit about how to make a popular open source project. So I posted PySnooper. I posted it I think a year and a half ago, and I put it on Hacker News and Reddit, maybe a couple more places, and it got really popular. It got on GitHub. It has 13,000 stars. I've seen lots of people tweet about it. I've seen people make YouTube videos about it in Spanish and in Chinese and a bunch of different languages and people all over the world. So that was really happy for me. Yeah, I've done a lot of open source projects in the past, and a couple have been successful, and most of them haven't. So it was very happy for me to make one that was so successful. So I'm gonna sort of try to share what I did to make it popular, because I know lots of people here might be interested in posting their own open source project. So I'm just gonna share what I did. So first thing is posting to Hacker News. Let's open the thread and Reddit. Right. Hacker News, if you don't know about it, it's a very nice aggregator. So I posted the GitHub page when I released it. I think, yeah, a year and a half ago, and same thing on Reddit on the Python community. I posted it there, get a couple of friends to upload it, and one thing that is very important is to have a good README. Or you know what, I'm going to go back a bit. One thing that's most important is to understand that when you try to publish your open source project and send it to a lot of people, that people have a very short attention span. They want to see something interesting, and they have maybe like 30 seconds of attention that they are willing to give to your page. So first of all, I used a tagline that I liked, which is never use print for debugging again. Same tagline as for this talk. And I wrote a README, and I really tried very hard to get my point across as quickly as possible. And this is longer than a README should be. I mean, this is pretty long, but I tried to get to the point. And also, it's very important to have a simple, short example as quickly as possible, a quick start, something that shows usage very quickly and succinctly. Then this is longer than you should have. I mean, I guess PySnooper is just that kind of project, but this is pretty long. And you should have an example that's even shorter than this. One thing that people really liked is what I wrote here. What makes PySnooper stand out from all other code intelligence tools? You can use it in your shitty, sprawling enterprise code base without having to do any setup. So that was really, to identify the pain point that PySnooper is solving, and just communicate that as succinctly as possible. So that's my recommendation. If you're making an open source project and trying to get it popular, make the README really get to the point as quickly as possible, and put an example on there. So that's something I recommend. Any questions so far? No? Okay, feel free to unmute yourself if you have any questions.
There's a few questions, if I can ask. So
Yeah.
there's one about how does PySnooper handle errors?
I'm not sure. You're talking about errors in PySnooper itself, or errors that come up in your program? I'm going to assume errors that come up in your program. So yeah, if there is an exception, you know what? Maybe I can make an example of that. Maybe I'm going to add here try 1 divided by 0. You know what? I've never done this in a talk yet, so I hope I'm not going to embarrass myself. Let's say there is an exception here, and I'm catching it, and I'm printing oops when that exception happens. Let's see what happens when I try to run it with PySnooper. And you know what? I'm gonna comment out the rest because I don't want to be confused by all the other text. Okay, so we see that the function started running. In this line, PySnooper is telling me that I got an exception. It's telling me which exception, and then it's showing me that the except handler was called, and then that oops was printed. And now you may be asking, what's happening if I don't catch the error? And honestly, I don't remember. Let's try it. Let's say I'm dividing 1 over 0, not catching the error. So obviously the error is going to raise up. So the error is raised, but PySnooper still does its work and shows everything that happened until the exception got raised, and then gracefully finishes before bubbling the exception up. So yeah, PySnooper seems to have done the right thing here.
Yes.
And there was another one?
Yes. that if there are any problems or limitations that you have encountered with this.
I think that we have, I mean, we had a bunch of bugs. You know, this is a good time to talk about the contributors. We have 24 contributors to PySnooper, people who have come and fixed bugs. There were a lot of bugs and implemented features. And the most prolific one has been Alex Hall. He solved lots of problems and helped review lots of code. Looks like he's looking for a job. So if you want to hire him, he's a great guy. So I used to have lots of bugs here and lots of people solved them. And there are still a few. Let's look at the issues. I remember, yeah, there is a relative time metric that fails when using generators. We didn't implement a sync await at all. So far, it seems that nobody really asked for that. So I don't know if people really use it. We would like to have colors. We like to have colored output. That'd be cool. So there are lots of things that we want to do. If you're interested in contributing, either take on an issue here or, you know, contact me by email and I'll be happy to get you started on a feature or a bug to work on. I'm going to talk now about another tool, a tool called PuDB. So it's a different tool, but I think it's very interesting and it's worth to know about it. I think most people have heard of a tool called PuDB, right? PuDB comes with Python. It's the default debugger that Python has. And it's sort of like it's a very famous debugger just because it comes with Python. And I haven't used it in years because I hate it so much. I mean, I tried to use it a bunch of times in the past and I made a variable called Q. And when I typed Q, it immediately exited. And I was very angry and I never touched PuDB again. And so now I'm going to talk about another tool it's called PuDB. So install it with pip install PuDB. Obviously, I already have it installed, and it's a sort of graphical debugger that works in the shell. This is very slow. Sorry about that. And the way you run it is you type PuDB and then your file name. I've got the same code here that I had before. Let's enlarge that. And it has something like a GUI that starts up in your shell, which is pretty amazing. Here's what the interface looks like. It looks like a GUI. It's in an SSH session, and it's kind of a full-fledged debugger. Like I can go through lines here, and I can like set a breakpoint. I can run the code until it hits the breakpoint, and then I can step through the lines. The most complicated part here is that I have to memorize the keyboard bindings. If I press question mark, I get a page with all the keyboard bindings. So you kind of have to remember that, you know, S steps into a function and what's it called? N steps over and C continues. So that can be tough to memorize. But after you memorize the bit of it, it's a very fun thing to use. I can go up and down the stack. I can open up a shell. There is a shell here that I can use to explore the variables. Right now I got it set to bPython, which is something like IPython. Sorry for the slowness. This is running on my Raspberry Pi. So I can look at the values of variables here, right? It's same kind of exploration we did before. I can run any arbitrary Python code here, right? And it's all in the shell that's in the debugged process in the exact place where I put a breakpoint. It's possible there are also conditional breakpoints here. I don't remember. So it's a tool that, I mean, it isn't nearly as powerful as Wing IDE or PyCharm, but it's a very cute tool because you can use it in any SSH session. So if you have a machine that you don't even know how to sort of connect to, or you don't know how to connect a real debugger to, so PuDB is a really nice option because you can just SSH in there, do pip install PuDB and just run it and get something like GUI in your SSH session. Like I think that the more older people in the audience will remember this is kind of similar to Boland C or Boland Pascal in the past, right? So you get a feeling of nostalgia. That's pretty cool. So that's pretty much it. Any questions about PuDB?
I do not see any questions, but if anyone wants to unmute themselves and
Cool.
ask. Yeah.
Cool. I'm going to talk about one last thing that was interesting for me. So when I was developing PySnooper, let's see some of the PySnooper code. Right. So PySnooper It has lots of code, lots of complicated code and logic that does all kinds of things. And I was developing it like any other software project. I was solving bugs, implementing features. Sometimes things didn't work, and sometimes I need to debug my debugger. And I realized I can't use a debugger the way I like on PySnooper. So that's kind of ironic. I love debugger so much. I made a debugger and I can't use a debugger on it. And why can't I use a debugger on it? That's because of a sort of a weakness of Python. So I've talked before about the sys.saturates function, right? And this is a sort of magic sauce that makes all debuggers work. You use the sys.saturates function to tell Python, please use this trace function to debug my code. And Python only accepts one trace function at a time. So when I was trying to run PySnooper in a debugger to debug PySnooper itself, it wouldn't work because the trace function of PySnooper was pushing out the trace function of the debugger. And one thing I would really like to see in Python is to be able to have multiple trace functions, one on top of the other. So instead of having sys.trace for just one trace function, I want to be able to have a sort of stack of trace function. First, like have the PySnooper one, and then I could have the trace function of the debugger so I could debug PySnooper. This applies not only to PySnooper, but to any kind of debugger or coverage measurement tool. I bet that lots of people know coverage.py, right? It's a very famous, where's the GitHub page? All right, it's a very famous tool by Ned Batchelder, right? I think it's probably the most popular tool for measuring coverage in your Python code. And it uses sys.saturates like any other coverage measurement tool. And you can't use coverage on coverage itself, or you can't use coverage on a debugger, and you can't use debugger on coverage. So being able to use multiple trace functions, one on top of the other, it would make it possible for people who develop these kind of code intelligence tools to use these tools when developing their tools. So that would be an interesting addition to Python. It's kind of a niche use case, I know, but if anyone would be interested in writing a PEP, I'll be happy to help. So that is one change I would like to see in Python itself. And I think I'm done. Any more questions? Does anyone have questions?
Yes, there's a few more questions that I can go over with you. So, someone asked, what about async code? I saw this coroutine is not supported as a message.
That is true. There is one feature we do not have. I gave it a try, and I sucked too bad at the async await stuff. And I saw that nobody really asked for it so far, so I figured nobody uses it. But if anyone would be interested in implementing it, I'd be happy to coach you. Feel free to contact me, or start talking find the issue on our GitHub and start to communicate there. And I'd be happy to guide you and tell you what you need to make it work.
Mm-hmm. And how could this be used in Django?
In Django, I've had people use it in Django, and that's the thing with PySnooper. You don't really need to think of how to use it in Django because you just put it on a function. You can either put it on a function, or you can also use it as a context manager. So I could do. I've shown it as a decorator before, and I can also do the following. I can do this. Use it as a context manager, and now when I run Python foo, it uses PySnooper in the same way. So that way I can use PySnooper not only on functions, but on any kind of segment of my code. So when you're asking how to use it on Django, it's like there is really no answer, because you use it on Django in the same way you use it on anything else. Just find a function or a piece of code that you got, wrap it in PySnooper, and just everything works. You don't really need to think of anything special that you need for Django.
Also, are there any good similar alternatives?
Well, I've just spent 10 minutes talking about PuDB, so yeah. But also there is also something similar to PySnooper that was called it's called file. I think it's called Python Hunter. That does the same thing. Basically, I think it also has colors, which is nice. And there is also a fork of PySnooper called Snoop, which has more features. Some features that I thought were not important enough to merge. And maybe there are more. Yeah, I don't know.
Okay. if there's any other questions, we can take for the next couple of minutes. Other than that, there is a lot of good feedback. Someone saying that you're a lifesaver and that this is very cool. But yeah, if someone wants to ask one last question, feel free to unmute yourself and ask a question, or just write it in the chat and I can read it out for you.
People are shy. I thought more people are gonna unmute themselves. Maybe someone here is not shy. No, okay.
That's okay. Uh, so I guess that's it. Thank you so much.
Yes.
Clearly, everyone's like super impressed, which is great. And yeah, as Ram said, you can always just write to him, contact him via GitHub, and I'm sure that he can help out with any more questions if they occur after this. But thank you so much. Thank you for joining us for PyCon and for this talk. And I also want to thank everyone who was here for this talk. It was a very insightful talk, very nice.
Thank you.
And now we can move on to our next session, which should be around in 8 minutes, I guess. So yeah, see you all in the next session.